Hello everybody, the topic on which I will be discussing in this particular lecture is nodal analysis. Okay, so before going further, we need to understand what is nodal analysis. Okay, we need to understand what is nodal analysis. So, as I have already discussed in my previous lecture, that whenever you are having some network which is having n number of nodes, okay, n number of nodes and b branches, in that particular case we will be getting n minus 1 node equations b minus n plus 1 KVL equations, okay, and b numbers of element equations. Now in case of nodal analysis, we will get the node voltages and different node currents using this n minus 1 KCL equation, using this n minus 1 KCL equation. So as we are using this particular KCL equations in different nodes and getting the voltage of different nodes and the current entering into the node or leaving from that particular node using the KCL equations or node equations, that kind of analysis is called nodal analysis. Okay, so going further, let us draw a certain circuit which is having certain elements and nodes. And one important thing is that most of the cases whenever doing nodal analysis in those circuits, the main active elements is the current source. Okay, most of the cases where the only current source are available or current source are there in the circuit, we use nodal analysis. So let us draw a particular circuit. So let us give the node numbers 1, 2, 3, and this particular node is grounded and we are giving that 4. Here the current, let's say I3, and here the current is I1, and give the element resistance numbering. This is connected only with node 1, so we are giving R11, here we are giving R12, we are giving R22, here are 2 3, here are 3 3. Okay, now let's say different currents going away from the nodes. Let's say this is I 1 2, this is I 1 1. From node 2, let's say this is I 2 3, and this is I 2 2, and here let's say this is I 3 3. Okay, and the node voltages, this one V1, this one V2, this one V3. Now if I set up the KCL equation at different nodes, this particular node, this particular node, and this particular node. Okay, if I set up the KCL equation of nodes, then what we will get at node 1, at node 1. Okay, at node 1, what will be the KCL equation? So whenever all the currents are going away, they are positive, and which is entering, that will be negative. So I can write that I11 plus I12 minus I1, which is equals to 0. Or you can write, in case of 1 1, this is the voltage V1 and here it is ground 0. So V1 divided by R11 plus V, here you can say V1 minus V2 divided by R2 will be I12, V1 minus V2 divided by R12, which is equals to I1. Okay, now if I write the resistances with respect to their conductance, then I can say G11 V1 plus G12 V1 minus V2 equals to I1. Okay, now if I rearrange this equation, then we can say V1 G11 plus G12 minus G12 V2 equals to I1. Okay, we got the first equation in node 1. Now let's write the equation of node 2. Let's write the equation of node 2. So if I consider node 2, all the currents going out from node 2 will be positive. So if I say this particular current and this current going out, so there will be I23 plus I22. These two currents are going out and here it is going in, so it will be minus I12 equals to 0. Okay, so if I rewrite the equation, then I23, what I can say, I23 will be V2 minus V3 into G23 plus I22 will be I22 will be V2 into G22, which is equals to I12. I12 I can write V1 minus V2 into G12. So V1 minus V2 into G12. Okay, so if I rewrite this particular equation, what we can get is minus G12 V1 plus V2 into G12 plus G22 plus G23. Okay, minus V3 into G23, which is equals to 0. So this is equation number 2. Okay, now if I write the equation for node 3, then what we get, current going into the node, that will be negative. Okay, and current going out, that will be positive, and here it is going into the node, it will be negative. So we can write minus I23. What I can write for node 3? For node 3 we can write minus I23, okay, minus I3 plus I3 I33 equals to 0. So obviously minus I23 will be V2 minus V3 into G23 minus I3 plus V3 into G33, okay, equals to 0. Rewrite the equation. We will get here no term of V1, so I can write V1 into 0, and for V2 we can write G23 V2, and for V3 we can write G23 plus G33, which is equals to I3. Okay, so we get the equation number 3. So let us write all the three equations one by one, and or we can say side by side. So equation 1, we are getting V1 G11 plus G12 minus V2 G12, which is equals to I1. This is equation 1. For node 2 we are getting minus V1 G12 plus V2 G12 plus G22 plus G23 minus V3 into G23, which is equals to 0. Okay, and for node 3 we are getting minus V1 into 0 minus V2 into G23 plus V3 G23 plus G33, which is equals to I3. Okay, so if I write this particular 3 equation in matrix form, how it looks like? So in matrix form, if you can say, I write it here G11 plus G12 minus G12 0. This is for node 1. Okay, and for node 2 minus G12, and the middle term is G12 plus G22 plus G23, and here minus G23, here it is 0 minus G23, and here G23 plus G33, and here it is node 1 voltage, node 2 voltage, node 3 voltage, and here the current pushed into the node 1, current pushed into node 2, and current pushed into node 3. Okay, so you can say this is the matrix form how the nodal analysis is giving a certain pattern in nodal equations. Okay, here important point we need to understand that in the right hand side of this particular equation, what we are getting is the current which is being fed or pushed into the node. Important, pushed into the nodes. So why I am saying pushed into the nodes? Here the positive sign is for the current which is pushing into the node. Okay, which is pushing into the node. So if I draw the equation, or if I draw the circuit again, let's say I'm drawing the circuit again. Here it is I1, here it is I3, here voltage V1, here voltage V2, here voltage V3, this one is grounded, which is VG4, which is 0. And if I draw all the resistances, this is R12, this is R11, R22, R33, R23. Okay, now from this particular circuit analysis, I have already given, or we have already get the nodal equations. But from looking at the circuit, if you want to write down the nodal equation matrix, how it looks like. Okay, so here you have to understand that first node 1, you have to check that what are the resistance connected to this particular node. Okay, so for first this one, only single resistance connected is R1, and from this one to this one we are having R12. So the first equation, the first element of the matrix will be G11 plus G12. This is, we can say, the self resistance. You can call it a self resistance. Okay. Now the second element is the only the conductor connected in between node 1 and node 2, and it will be put with minus sign G12. And for third, what is the inductance, what is the resistance connected in between node 1 and 3? So you can see from this particular figure, there's no resistance is connected in between 1 and 3. So in that case, it will be 0. Similarly, if I go to node 2, this is for node 1. If I go to node 2, first what we have to check, that what are the resistance connected in this particular node. So this one is connected, this one is connected, and this one is connected. So here the conductance value has to be put G12 plus G22 plus G23. And next we have to see that what are the resistance are connected between 1 and 2. Okay, sorry, I made a mistake here. First we have to let us rewrite that. Okay, let us rewrite this equation again. Okay, let us rewrite this equation again. Now what has to be done, let's say the equation or matrix should be like this: A11, A12, A13. Okay, V1, V2, V3, and current pushed into the system, let's say I1, I2, I3. Okay, and the second element 1, 2, 1, 2, 2, 2, 3, A31, 3, 2, A33. Okay. Now here we have to check what does it mean by A11. A11 is all the resistance connected in node 1. A12 means all the resistance connected in between node 1 and 2. 13 means all the resistance connected in between 1 and 3. 21 means all the resistance connected between 2 and 1. A22 all the resistance connected in only node 2. All the resistance connected in between 2 and 3. All the resistance connected in between 3 and 1. All the resistance connected in between 3 and 2. All the resistance connected in node 3 only. So if I let us copy this particular thing. So with respect to what I have said previously, that how the matrix will be look like. So first element is A11, that all the resistance connected in this particular node only. So this is R11 and R12. So we will write G11 plus G12. Then here the element, this is A11. Similarly A12, this one. So it will be written in minus G12. A13 is 0. A21 obviously G12. A22, that means all the resistance connected in node 2. Here G12 plus G22 plus G23, and 2 and 3 is G23 and it has to be minus. Okay. Similarly for node 3, here the element is 3 1, that means all the resistance connected between 3 and 1, that is 0. 3 2, that is this R23. Okay, minus G23, and G33, that is all the resistance connected in node 3 only, in this particular node only, that is G23 plus G33. Okay, and here we will be writing V1 node 1, node 2 voltage and node 3 voltage. Okay, and here it will be all the current pushed into the node, that is I1 pushing into V1 positive. In node 2 we are not having any current source which is being pushed into V2, that is 0, and this one is I3 which is being pushed into node 3. So you can see that without writing down the detailed nodal equations, by checking the circuit only, we can come down to the matrix form of the equation. So that is very important. We need to practice a lot to implement that equation. And important point to remember that when we prefer nodal analysis when all the active sources, all the active sources are current source. That is important. This is important. Okay, so let's close the lecture for this particular session. I will be coming with the next topic in my next video. Okay.